What's up with that? Well, these ones are available online. I'm going to show you how to find it. It's a weird quirk. I can't even tell you what year it was, but it was more than 20 years ago. The previous, I'll say third edition, was a hardcover that had 10 chapters. There was a time I actually used to do chapter 10, but chapter 10 really became irrelevant as technology improved in matrix theory in general. Chapter 10 was a way of doing iterative techniques. Think like Newton's method with matrices. It was nasty, but it really became irrelevant. And I was the only one that covered it, so I stopped covering it, but I still cover 8 and 9. 8 may be the most important chapter in the entire book. 7 is the most important, and 8 is the complex version of 7, which is what you need for all of your upper division stuff. And the author came out, the publishers came out with a 7-chapter book, the next edition. So hold on. They said, well, no one's covering those, so why waste the money in printing it? And I said, I do. So we're not going to use this anymore. So they came out with a special Mesa College edition. I have it. It's a soft cover, and it says right on there, Special Mesa College Edition. And I always call that's the golden ticket if you can acquire that one. It's a 4th edition. They're extremely rare. I have one, and it has all 10 chapters. But even the color of the pages of the last 3 aren't exactly the same because they put them back in. And then they decided, you know what, it's too much work. We'll just put them online. So for the last 20 years, they put it online. And people are like, well, can I then get the whole book online? Well, not legally, but anybody can get the last 3 chapters because they made that public. So we're going to cover a couple different things. Now, if you've had statistics, you may be familiar with this, and we talked about this on day 2. There's 2 types of analysis to come up with equations. There's polynomial curve fitting, which is what we did on day 2. If I give you n distinct data points that don't share x coordinates, there's a polynomial of degree n minus 1 that passes through all of them. Okay, that's a major thing. That's called polynomial curve fitting. But that's its own separate branch altogether. What if I basically just gave you a whole bunch of data points? If you've had statistics, this is not a big deal. What is this picture called? Does anybody know? There's a name for it. It's called a scatter plot. And when I'm looking at a scatter plot, I say, this has kind of an uphill tendency. And it's not